Okay, we're going to continue on a 6.2. We're talking about a little bit about special right triangles and then some application type problems. Okay, so here are special right triangles, as you may have learned in geometry or FST. This first one is a 45, 45, 90 triangle. This one's called a 30, 60, 90 triangle. When you have a 45, 45, 90 triangle, you have a special relationship of all three sides. The two legs will be x, and the hypotenuse is x root 2. On the 30, 60, 90 triangle, the longer hypotenuse, obviously the hypotenuse is always the longer side, is 2x. The shorter leg is x, and we call this the height is x root 3. So as an example, if I had something, let's say in the 45, 45, 90 triangle, if x were 5, that means that this leg would also be 5 because it's a special right triangle, which makes the hypotenuse 5 root 2. All right, that's for a 45, 45, 90 triangle. For a 30, 60, 90 triangle, I'll make it a little bit more challenging. Let's say that this right here, this height of the triangle, let's say this was 10. So it's going to get a little challenging. But now we set x root 3 equal to 10, and then we solve it. Divide by root 3, divide by root 3, even rationalize that, and x is actually 10 root 3 over 3. So this right here of the triangle, x would be 10 root 3 over 3, and 2 times that, right here, 2 times that would be 20 root 3 over 3. That's for the 30, 60, 90 triangle. Keep in mind these can be in radians, where this would be pi over 4 and pi over 4 and pi over 2 for the 90. And for the 30, 60, 90 triangle, this would be pi over 6, this would be pi over 3, and again, this would be pi over 2. So let's look at solving a triangle. This is a special right triangle. It's a 30, 60, 90 triangle. Obviously, it's in radians. That's pi over 3, which I just stated would make this angle pi over 6. That angle A is pi over 6, so we have that already done. If you remember that 3 angles in a triangle add up to 180 degrees. And now we can look at the special relationship of all three sides. BC, if BC is 10, that will be our x. This is x root 3, and this hypotenuse would be 2x. So if x is 10, that makes AB, or little c, that makes this 20. So little c would be 20. And side AC, if x is 10, that will make this 10 root 3. So that'd be little b would be 10 root 3. Okay, the second example, a little bit more challenging. We've called it triangle ABC. This is not a special right triangle, but we do know one of the angles is pi over 7. I just rewrote that because it was hard to read. That angle is pi over 7. Since this angle down here at C is pi over 2, we know that we have 90 degrees remaining between angle A and angle C, or angle B. We have 90 degrees, or pi over 2. Pi over 2, if that's all we have left over, because angle C is pi over 2, that's already part of our triangle, which is 90 degrees. If I have pi over 2 remaining for angle A and angle B, I'll take pi over 2 and subtract pi over 7, get a common denominator. So I can multiply top and bottom by 7 here, multiply top and bottom by 2 here. That leaves me with 7 pi over 14 minus 2 pi over 14, which equals 5 pi over 14. And that is the measure of angle B. So there's angle B. Okay, so now that I have that, I can find x and y. With that said, I can use angle B or I could use angle A. I'll use angle A since angle A was given. So if I want to find, let's say we want to find x first. Let's find x. Well, let's look at the relationship of the sides, and then let's use SOHCAHTOA. So if I'm looking at angle A, 22 is opposite. So 22 is opposite the angle A. And I'm finding x that is adjacent. So that tells me from SOHCAHTOA that I'm going to use tangent. So tangent of my angle pi over 7 equals the opposite, which is 22, over the adjacent, which is x. Multiply both sides by x, divide by the tangent of pi over 7, and x will equal 22 over tangent pi over 7. That is your exact answer for x. Now, if they wanted the decimal form, you go ahead and throw that in your calculator. Make sure your calculator is in radians. Same process to find y. 22 is opposite. Let's put it over here in green. 22 is opposite pi over 7. We're trying to find y now. Y is the hypotenuse. And so OH from SOHCAHTOA would say use the sine. So the sine of pi over 7 equals the opposite, which is 22, over the hypotenuse, which is y. Multiply both sides by y, and then divide by the sine of pi over 7, and y would equal 22 over the sine of pi over 7. That's the exact answer. Again, if you want the decimal answer, you'd go ahead and divide that in your calculator, and you would make sure your calculator is in radians. Now, let's talk about a few things called line of sight, angle of elevation, and angle of depression that we'll use for our word problems. Line of sight. The line of sight generally has to do with the way that a person looks at something. So line of sight. Usually it's going to be to the horizontal. And so if I say line of sight, like looking directly horizontal, that'll be looking straight ahead from a person. Angle of elevation is always going to be elevating up, like so into that diagram. Angle of depression, that's looking down. But I want you to think about something. If you remember from geometry, that that alternate interior angles are congruent. So the angle of elevation and angle of depression will always be the same angle within a triangle. That's going to be helpful when we look at angle of depression. All right, so here you can see angle of depression, and this would be the angle of elevation. Those two angles are the same by alternate interior angles. Here's an example. A 20-foot ladder leans against a building. So I'm going to label the ladder 20 feet. If the base of the ladder is 6 feet from the building, I'm going to label that. This distance here is 6 feet from the building. It says, what is the angle of elevation? So we're trying to actually find this theta. All right. So using SOHCAHTOA, we notice that we have adjacent and the hypotenuse. So adjacent and hypotenuse, according to SOHCAHTOA, is the cosine. So cosine of theta equals the adjacent, which is 6, over the hypotenuse, which is 20. Now to solve for theta, we're going to take the inverse cosine of both sides. So if I take the inverse cosine of both sides here, sorry about that, inverse cosine of both sides here, that leaves me with theta equals inverse cosine of 6 over 20. Now that would be the exact. Now you could simplify the 6 over 20, but that would be the exact answer. If you throw that into your calculator, you'll get theta to be 72.5. Theta equals 72.5 degrees. Don't forget the degree mark. There you go. So another example, a little bit more complicated, but it says from a point on the ground 700 feet from the base of a building. So 700 feet from the base of the building. So here's the point from the building, 700 feet right there. It says it is observed that the angle of elevation to the top of the building is 21 degrees. So this angle, let's fix that in there. So this angle here is to the top of the building. That's the angle of elevation to there. They're saying that is 21 degrees. Then it says the angle of elevation to the top of the flagpole is 23 degrees. So that means that this angle all the way up here is 23 degrees. Now it says find the height of the building. So if I want to find the height of the building, I'm going to find H. That's this height of just the building. And then they say find the length of the flagpole. Now I'm going to find the entire height from the bottom of the building to the top of the flagpole. If I find that, if I want to find the length of the flagpole, so if I want to find this length of the flagpole here, I can go ahead and subtract off that full height F and H, and that will give me the height of the flagpole. So let's do it. Let's first find the height of the building. Again, using SOHCAHTOA, I have adjacent for the 700. That's this here. And the height of the building, that's opposite. So adjacent and opposite. And actually, I probably would have said opposite and adjacent. That's opposite and adjacent. That's tangent. So tangent of 21 degrees equals the opposite, H, over the adjacent, 700. If I solve that for H, I will get H to be 268.7 feet. Make sure your calculator is in degrees. If I want to now find the F, I'm calling it F, I would use, again, opposite and adjacent, because this F is opposite and the 700 is adjacent. That's tangent. So tangent of 23 degrees now, so the top of the flagpole, equals F over 700. Again, solve that for F. If I solve that for F, I would get F would be, if you throw that in your calculator, multiply both sides by 700, F comes out to be 297.1 feet. Now, that's not what the question was asking, but now if I take those 297.1 minus 268.7, that will be the height of the flagpole to be 228.4 feet. One more here. I just want to show you the angle of depression and how it's the same thing as alternate interior angles would be the angle of elevation. So we won't do this example, but I'm just going to show it to you, then you can practice on your own. A police helicopter is flying at an elevation of 2,800 feet. So this height would be 2,800 directly above a straight highway. Two motorists are driving cars on opposite sides of the helicopter. So you got one car here. That's my best drawing of a car. Okay. Take it for it as it is. Here's another car. Yep. There you go. They're driving on opposite sides of the helicopter. The angle of elevation, or excuse me, the angle of depression to one car is 72 degrees. So this angle is 72 degrees, and the other is 51 degrees. This is how far apart are the cars. Now, of course, like I said about alternate interior angles, if the angle of depression is 72, this angle of elevation is also 72 degrees. And over here, if that's 51 degrees for angle of depression, this angle of elevation is also 51 degrees. So if you want to practice this one and try to get the right answer, you notice that will be your correct answer, 3,177.2 feet. What you basically do is do two different problems, finding this side. It's like you use opposite and adjacent, so that'd be tangent. And then find this one, again, using the tangent, and then add them up. So that's the completion of 6.2. Let me or Ms. Zara know if you have any questions, and we'll be sure to help you out.